In this video, I have taken two similar questions, third and fourth part from the chapter maxima minima application of derivative. So in this question, we have to find the local maximum and local maxima and local minima, if there any. And also we have to find the local maximum in case if it is local maxima and local minimum. So I've taken the three questions. In the first question, this is the hx is equal to given as sin x plus cos x, where x varies from 0 to pi by 2. That is the first quadrant. So the very first thing that we will do is to find f dash x. From here I can see f dash x, sin x derivative is cos x, and cos x derivative is minus sin x. Now, we'll also find its second order derivative to be used later, f double dash x. Cos x derivative is minus sin x minus as it is, and sin x derivative is cos x. That's what we get from the second order derivative. Now, for maximum or minimum, f dash x should be equated with 0. So equating this with 0, I'll get cos x minus sin x is equal to 0, or cos x is equal to sin x. That implies tan x is equal to 1. And now we have to consider the quadrant here. Let's say here we are considering the quadrant from 0 to, is given 0 to pi by 2. And from 0 to pi by 2, tan is negative only once when it is pi by 4. So we can say that, well, it is important to consider, remember that we are just considering this quadrant that is from 0 to pi by 2. And that's why we'll take only one critical point or the extremes values of tan x as pi by 4 only. And as I said, the reason here is just because we are considering the first quadrant. Had it been 0 to pi by 0 to 2 pi, then we could have got another angle where the tan x is equal to 1. So we got x is equal to pi by 4. Now I'm going to check the sign of f dash x at this critical point. That means f double dash x. Sorry. Now placing from here, right? It is minus sine pi by 4 minus cos. This is cos pi by 4. This will give you minus 1 by root 2, and then again minus 1 by root 2. That is minus root 2 is what you are going to get. As you can see that f double dash x here at pi by 4, we are getting negative. Therefore, we'll say that pi by 4. Therefore, I can write above. Therefore, we can say that pi by 4 is the local. This is less than 0, right? So in case of less than 0, that is negative, we say local maxima. And the maximum value, therefore, the maximum value is obtained by placing the value of, it is hx. By mistake, I took fx, but that's okay. We can rectify it later. So f dash pi by f pi by 4. We have already found out the turning point. Now we are going to find the maximum or the minimum value. So here it is a maximum value is f pi by 4. That is sine pi by 4. Well, you should know where from I'm taking it. I'm taking it from here, right? So f pi by 4 plus cos pi by 4. So this is 1 by root 2 plus 1 by root 2. That is root 2 again. So once again, we'll say that the maximum value is root 2. And we'll also say that pi by 4 is the point of local maxima. So if I have to conclude the final answer, I'll say that the local maxima is pi by 4, and the local maximum value is root 2, and there is no local minima, or that's the reason why I do not have local minimum value. Now moving to the second part. Similar to the previous part, this time the function is sin x minus cos x, and we have x varies from 0 to 2 pi. So you should remember that we have to take one complete circle, that is from 0 and back to 2 pi. That is, this is only 2 pi. Well, this is pi by 2, this is pi, and this is 3 pi by 2. Now let's first find out the f dash x as we used to do. So we'll find f dash x. Sin x derivative is sin x derivative is cos x, and cos x derivative is minus sin x. That's why minus and minus is plus, so it's plus sin x. Now, as I said, we'll also find second order derivative. So cos x derivative is minus sin x, applying second order derivative, and sin x derivative is cos x. Now from here, we'll equate f dash x with 0. For maximum or minimum, we put f dash x equal to 0. That means cos x plus sin x is equal to 0. That means sin x is equal to minus cos x, or we can say that tan x is equal to minus 1. Now we got tan x is equal to minus 1. What we know that tan pi by 4 is 1, but we need minus. We know that tan is positive over here and over here. That means negative will be at this and in this quadrant. Now we know that an angle in this quadrant is written as pi minus theta. So I can say that this is tan pi minus pi by 4 is equal to tan minus 1. Tan, as we have minus 1, so I can say minus 1. So we can say that this is tan x here. Comparing this angle with this, I can say that x is equal to 4 pi minus pi, that is 3 pi by 4. Now further, we can also conclude that an angle over here is tan is negative, and this is written as 2 pi minus theta. So we can say that tan 2 pi minus pi by 4 is equal to minus 1. So again, comparing this with this, x with this, we can say that, let me write down properly, it's not clearly visible. That is equal to minus 1. So we'll say x here is 4 to the 8 minus 1, 7 pi by 4. Now we got this, and then we have two extreme values. One is this, another is this. We'll use the second derivative test to figure out which is the point of maxima and the point of minima. So if I say plug in f double dash 3 pi by 4. So we have minus sine 3 pi by 4 and plus cos 3 pi by 4. So now f double dash 3 pi by 4, this is minus sine. We know that 3 pi by 4 is pi minus pi by 4, and same way cos 3 pi by 4 is pi minus pi by 4. Now pi minus pi by 4 is what? Is this quadrant, right? And in this quadrant, sine is positive. That's why we'll get a positive value from here, that is positive 1 by root 2, right? And positive 1 by root 2, but there is a minus sign outside, so I'll write minus 1 by root 2. Now for this part, this is cos pi by 4, but in which quadrant? In the second quadrant, right? Pi minus pi by 4, second quadrant, and cos is negative over here. That's why we'll write minus, and minus sign will pop out, and we'll make this also minus. So what do we get here is minus root 2. Now check here, minus root 2 by second order derivative test. As you can see that f double dash 3 pi by 4 is less than 0. So we'll consider this point as the less than 0 is point of maxima. This is point of maxima. I can eliminate some of the portion to do the remaining part from the screen. Now I'm going to first in the second point, that is this one. For f double dash, this is 2 pi by 7 pi, right? It is 7 pi by 4 is equal to what? This is minus sine from here, 7 pi by 4 plus cos 7 pi by 4. So this is what? Minus sine. I can write 7 pi by 4 as 2 pi minus pi by 4. And same with cos, that is cos 2 pi minus pi by 4. Now, what do we realize here? That this is second quadrant and sorry, fourth quadrant, right? 2 pi minus pi by 4 is fourth quadrant, and sign is negative over here, but then there is a minus sign. So minus and minus make it plus, because the minus sign will pop out and will make this positive. So we'll get positive 1 by root 2. Second quadrant, in second quadrant, cos is positive. That's why we'll get positive 1 by root 2. And therefore, root 2 is the answer. So we realize that here, what do we realize? That f double dash, that is second derivative test by second derivative, this is coming greater than 0. So we'll declare this point as this is the point of local minima. So once we have got the local maxima and the local minima, we have got the local maxima, we have got local minima. Now the remaining part is to find the maximum and minimum value. Now we have to find out local maximum and local minimum value. So for that, I need to erase a part of the screen. Let's say if I erase. All right. Now, once we have got this as the point of local maxima, let's find out the local maximum value, and the maximum value is attained by placing the value of, that means here, f from here, right? So this is f 3 pi by 4 is the point of maxima, or the point of maxima. Therefore, we'll get maximum value by replacing x with 3 pi by 4 minus cos 3 pi by 4. Now what we have as sine 3 pi by 4 can be written as pi minus pi by 4. And likewise, cos 3 pi by 4 is cos pi minus pi by 4. This is sine pi by 4. And we know that cos, this is second quadrant, and second quadrant cos is negative. So minus sign will pop out and we'll make it positive pi by 4. So finally, we have 1 by root 2 plus 1 by root 2, which is equal to root 2. Now we'll declare this as the maximum value, local maximum value, right? Or the local maximum. Now, once we have done this also, now we'll find the local minimum. And to find the local minimum, we're simply going to replace, right? That's better. If I replace this 3 pi by 4, I'm replacing this 3 pi by 4 with 7 pi by 4. So this will turn out as 2 pi minus pi by 4, same as 2 pi minus pi by 4. We know that sign is negative. This is fourth quadrant. Sign is negative over here. So we'll write down this as minus sign pi by 4. And this is positive here. So minus will remain minus. And since cos is positive in the fourth quadrant, that's why we are getting positive cos pi by 4. So this is minus 1 by root 2 and again minus 1 by root 2, which is minus root 2 on simplification. So we'll now declare this as the minimum, local minimum value. Now, so we could do this question finally that we have found out the local maximum and the local minimum in this case. Yeah, for understanding, you can see I've also made the graph for the second part, and you can see, observe from here that the local maximum value is under root 2, which is approximately 1.414, and the local minimum value is this, that is minus root 2, which is minus 1.414.